Okay, I mentioned in an earlier video that turning is accelerating, and I said that I was going to prove it to you. So here's how I want to do it. I want to imagine a road that goes like this, and then there's a turnoff that goes that way, or you could keep going straight. So here's our road, and I'll use orange. We'll draw a car right here, and we're going to say this car is going east at 40 miles per hour. So that's its velocity original, 40 miles per hour to the east. But we're going to say that in the future, instead of going straight, instead of going over there, we're going to say that the car ends up here and it's going south. So we'll call that our velocity final, and that's going to be south at 40 miles per hour. And here's the kicker. This is what makes it kind of a big deal. We're going to say that as the car went through the turn, the driver was very careful to keep the speedometer at 40 the whole time. So if we say that he's keeping it at 40 the whole time, a lot of you are instantly going to say, oh, well, if it's 40 the whole time, then nope, they're not accelerating. And I'm going to explain to you why that's not true. You are accelerating. So let's go back up here. Our velocity original was 40 miles per hour to the east. But after as he makes the turn, what happens to his east speed? Because down here, he's not going east anymore. So that means his velocity final is 0 miles per hour to the east. So if we've got a velocity change from 40 to 0, that means we accelerated, even though we kept the speed the same the whole time. Likewise, look at this. The south velocity, what was the person's original south speed or velocity? Their original velocity to the south was 0 miles per hour, because when they were up here, they weren't going south at all. They were only going east. So as they made the turn, their velocity changed from 0 miles per hour to the south to 40 miles per hour to the south. So that means they accelerated. This number up here would be negative because the velocity went down, and this number down here would be positive because the velocity went up. But even though this person kept their speedometer at a constant 40 the whole time, their velocities did change. So that means they were accelerating. I want to show you one more example. Okay, here's another example. Let's say that this direction right here is south. So as they're coming down this hill, they're going to the south. And then let's say this curve turns 90 degrees and they wind up going east. Okay, so I want to talk about their velocity original and their velocity final in both of these cases. So let's do this. I'm gonna use 40 again because that number's in my head from the last example. So what we're gonna say, their velocity original, when they were up here, their velocity original was 40 miles per hour to the south. Okay, that means their velocity original to the east was 0 miles per hour to the east. Do you understand that? As they're coming south, they're not going east. So their south speed, their south velocity was 40 miles per hour, and their east velocity was 0 miles per hour. Okay, so let's move on from there. As they go through the turn, what happens to this south velocity? It changes because at the end of the turn, they are no longer going south. So their velocity of 40 miles per hour to the south becomes 0 miles per hour to the south. And what happens to their final velocity to the east? That goes from 0 miles per hour, and assuming that they keep their speedometers at 40, their final velocity is 40 miles per hour to the east. And as you already know, if your velocity changes, what does that mean? that means that you must have been accelerating. So maybe I'm getting a little bit ahead of you here, but there is proof in this picture that acceleration happens. If you look at this biker especially, what is this biker doing? This biker is leaning which way? He's leaning toward the east. Well, why do you have to lean? The only reason you would have to lean would be because there's some kind of a force acting on you. And we're not to forces yet in this class, but we will be soon. So whenever you have a force that causes something like this to happen, that means that there must be an acceleration. Because forces can cause accelerations. So whenever you go around a curve and you have to lean into that curve, that's proof that you are being accelerated in the direction toward the center of that curve.